Hello, further to my previous video showing the freezing up of an air source heat pump that I have installed in a new property. In this video I'm just going to go through a few tests and checks that I need to do on the pipe work in the plant room. So I'm just going to go through a few of the results and some of the remedial action I'm proposing to take. As you can see, on this day it's well above freezing and no problems with the heat pump. I have got 3 thermometers placed at different positions on the installation. I have also fitted a couple of paper streamers just to indicate the flow of air coming from the heat pump. At this point I'd like to thank everybody that gave both good and bad feedback on the last video. As requested, what you can see here are the heat calculations for the property where the heat pump is installed. The heat pump is not quite performing up to expectations. To sort this out, what I'm doing here is increasing all the zones up to about 30 degrees C and opening every zone and TRV. By doing this, I will be controlling the heat inside the property purely by the flow temperature coming from the heat pump. On the heat pump interface, I've set the flow temperature to approximately 35 degrees C. While I'm testing this, I'm also going to do some tests of the temperatures running through the pipework in the plant room. If you haven't already done so, I wonder if you'd consider subscribing. It is free and it really helps. So this is the plant room, or the back of the garage as I like to call it. So to take the temperatures of the various flows and returns, I'm going to use my old gas analyzer. I find it quite reliable for taking flow and return temperatures and giving the readout of the delta T. Firstly, I'm going to check the temperatures of the flow in to the buffer vessel from the heat pump and the flow out to the heating. I do this by attaching the large crocodile clips to the 28mm pipework either side of the buffer tank. As you can see, there's a 3 to 4 degree temperature difference between the flow in and the flow out. Next, I'll measure the flow temperature into the buffer vessel and the return temperature out of the buffer vessel. My target delta T is 8, but here you can see the maximum delta T I can achieve, or is being achieved, between the primary flow and return is 5.7. The next check is between the primary flow from the heat pump and the central heating return. As you can see, this has exceeded a delta T of 8. Up next is the delta T between the heating flow and the heating return. This is also a delta T of 8.6. Now I'm going to check the delta T between the underfloor heating flow and return pipes. Here you can see the delta T between the underfloor heating flow and return is 8. Next up are the flows and returns from the radiators. Now the delta T between the radiator flow and return is approximately 3. This isn't right. There is some action that I've got to take here. So after taking on board a few comments from the previous video, initially I've decided to delete the underfloor heating pump and the associated mixing valve and fit the pump that is currently serving the radiators onto the secondary flow from the buffer vessel. I know some of the comments have been to change the buffer into a volumizer, but at this point I think I'll just keep the buffer vessel as a low loss header. I realise everything's not up to max working temperature at this stage, but in this diagram I've shown what I think's going on. I think the radiator circuit is the offender in this case, so my aim is to get that delta T up to around 8 from the radiators. So that's it until the next update. If you've liked and subscribed, I thank you for your subscription. So if you're now bored of all this, perhaps you might want to try my other channel, Land Rover TD5 Preservation.